and it's going over kind of more scientific-based problems, I guess.
You think I can clear up log functions real quickly for you if you want me to?
Okay, yeah, that'd be great.
Let's do it. All log functions begin with this, an exponential function. Okay?
Got it.
This is not algebraic, it's exponential because the variable x is in the exponent. That's what makes it an exponential function.
Okay.
Every exponential function has a log representation. In other words, this particular exponential function I can also write logarithmically. And you only have to know one thing to figure out what this is. Logs are exponents.
Okay.
R means the equal sign. That means on the other side of the equal sign has to be x. Where does the b go?
Next to the log?
Right down there is a subscript, which leaves the only other thing, y, is like that. An example, 8 equals 2 cubed. Write the logarithmic expression of that.
Let's see. Log base 2 to the power of 8 equals...
Not the way you verbalize this is log base 2 of 8
Okay.
equals what?
3.
Okay. At least that's the way I do it. I don't know if all teachers do it that way, but to me it's log base something of, I call this the argument, but the main thing is logs are exponents. Okay? So you want to be able to take any algebra or exponential expression and turn it into a log expression, and you want to be able to go the other way. And you have to do about equal amounts of each. So get very comfortable with going both directions. In other words, if I take away the exponential and give you strictly the log expression, what's the exponential expression of that?
It would be 8 equals 3 to the power, or 2 to the power of 3.
Yeah, I have kind of a special way I memorize it. I don't know. Memorization is tricky. Different things work for different people, but for me, I always go the number on the far left raised to the power of the number on the far right equals the number in the middle. So I would have said 2 cubed equals 8. And that's certainly the same as 8 equals 2 cubed, but just my little technique for memorizing it.
Got it. Now, how does a log look like on a graph?
Okay. All logs pretty much look like this. And they all go through this point right there, which is 1, 0, no matter which it is. In other words, if I don't put any labels on the x and y axis, that could be y equal log base 10 of x, where that's x and that's y. But it might also be, it could just as easily be y equals natural log of x. You know what natural log means?
No, I don't.
Means log base e. That's the same as log base e.
So to undo natural log, you have to use e?
Well, e is approximately 2.71. But it's a little like pi. You never really use its number. It's an irrational number that goes on and on forever without repeating.
Right.
And so the most accurate representation of this number is that, e. Okay?
Okay.
Furthermore, so I'm almost never converting this to 2.71. But furthermore, when you get into calculus, natural log is like a magical thing in calculus, just like E is.
Okay.
And almost all calculus, you're going to be doing natural log. So if you have any intent upon going forward, you're going to be working with a lot of natural logs. But that's all it is. It's just a short way of writing log base E. Now, when I say that all log functions look pretty much the same, well, unless it's, y equal log of that minus 2. And then that's a vertical shift down. Or if I said y equals natural log of x plus 3, that's a horizontal shift. So these things can change direct or, be anywhere relative to the x and y axis, but they all have this general shape.
Okay.
And this is the flattest function you have ever found. By that, I mean you have to go 2 miles in that direction in order to go up by 12 inches.
Wow.
But nonetheless, it still goes upwards to positive infinity.
Okay.
In other words, it does not merely approach a horizontal asymptote. In other words, the way I've drawn it, particularly, you might be tempted to think, oh, that looks like a horizontal asymptote right there, that it never reaches, but not true.
Mm-hmm.
Not true. It
Okay.
does not have a horizontal asymptote. Has vertical asymptotes. In other words, x equals 0 is a vertical asymptote. If I
Mm-hmm.
keep going in this direction, I never quite touch the y-axis, just get closer and closer to it. What does that mean? It means you cannot take the log of 0. This
Okay.
is pretty much the same as taking the square root of a negative number.
Okay.
Okay? In fact, log is more restrictive than square root. If I said y equals square root of x, you'd say the domain x has to be greater than or equal to 0. But if I say
Mm-hmm.
y equal log of x, domain is x has to be greater than 0. Not only can it not be negative, it cannot even be 0.
Okay.
Now, I'm trying to go through this quickly, but I guarantee you that you want to know all of this stuff. So
Yeah, that would be great.
it's never going to hurt. There's 3 primary rules that apply to logs. One is if you take the log of 2 numbers that are being multiplied, that's the same as the log of A plus the log of B. It's kind of a magical property of logs that allow a slide rule to work, all kinds of cool stuff. And the third one is the log of A raised to the B power equals B times the log of A. And this might be the most important one of the 3. It's the third one.
Okay.
Now, again, you need to be able to be proficient going either ways. When you get into this, if they haven't gotten into it yet, they're going to ask you to expand, which is going in that direction, and they're going to ask you to condense, which is going in that direction. In other words, they might say, what is the log of 8 minus the log of 4 equal to? What is it?
So if it's minus, we're using a second kind of rule here, right?
Uh-huh.
Okay. So would it just be log 8 over 4?
which is the log of 2.
Okay.
Okay? So that's what I mean by being able to go both ways. You need to be able to go from left to right and right to left.
Okay.
All right, that's my basic log lesson. Doesn't take too long, 12 minutes. Now let's have a look at some of the problems you have here. You don't necessarily need logs to do all of these problems. We might need logs to do some of them. Hold on. We're starting with 18, correct?
Sorry?
We're starting with 18?
Yes.
Okay. So we've got, whenever you do these problems, the very first line you want to almost always write is the general formula.
Okay.
Now, whenever you're doing growth, exponential growth, there's generally 3 general formulas that apply.
Okay.
One is when you're compounding annually. Another is when you're compounding more often than annual, which is like 23. In other words, let's label this annual, and then greater than annual, meaning like monthly. Then A equals P times 1 plus R over N to the NT, where N is the number of times per year you're compounding it.
Okay.
And the third one is continuous. And this is really the real one. By that, I mean nature, everything is continuous. Whether you're dealing with growth, as in like bacteria in a petri dish would grow continuously, or if you're dealing with decay, like uranium-238.
Okay.
All natural world functions either grow continuously or they don't grow at annual or more often than annual. These are human creations. In other words, banks decided that they would offer people annual compounding. And if you're doing annual compounding, you're using that formula right there.
Okay.
If you're doing more often than annual, another bank creation, you're using this formula right there. In other words, if I was doing monthly, I would use this where N is 12 and that N is 12. But most things, you would always be using that.
Now, is the E replacing the 1 plus R in that case?
Yes, it is. It turns out that if you let N go to infinity, which is what continuous compounding basically does. In other words, you can compound monthly where N is 12. You could compound daily where N is 365. Well, you could compound minutely where N would be some bigger number than that. But eventually, if N reaches infinity, it turns into this. And that's what continuous compounding is. And the definition of E is the limit of this thing as N goes to infinity. That's where E comes from, the number. And the reason it's such a key number, probably the second most important number in all of math, is because that's the way the world works, is based on E. So on 18, let me erase this because 18 is based on annual compounding. what they're going to do is give you 3 of the 4 variables. Notice that I've got final amount, beginning amount, that's 2, the rate, that's 3, and the time, that's 4. So
Okay.
they're going to give you, with each of these problems, they're going to give you 3 of the 4 variables, and you have to figure out the 4th.
Okay.
Okay? So what should I fill in for 18? What's the next thing I should write?
Should be 30,146 is equal to P
Which is what they're wanting us to answer.
times 1 plus 5.3.
You can't use percentages in equations.
So 0.5 or
0.0.
0.053.
I guess I shouldn't say you can't. I mean, I could write an equation that uses a percentage sign, but you always want to convert percentages to numbers.
Okay.
So it's 0.053. That's being added to 1. That's not an exponent. And then t is
7.
Now, t isn't always in years.
Okay.
Sometimes t is not in years, especially with continuous compounding. T can be in minutes or seconds, but it's related to whatever r is. If r is in years, then t is in years. If r is in minutes, I mean, maybe we've got the blob and it's growing by 5.3% every minute.
Okay.
Then my R would be 0.053, but my T would be in minutes, not years. So the units that go with T match the units that go with R. Pretty much. I hope that'll become more clear. It might not become totally clear until we use continuous compounding. Now, don't need logarithms to solve this. This is the same as P times 1.053 to the 7th power, which means P is equal to 30,146 divided by 1.053 to the 7th. That's going to be P. That's all pure algebra.
Okay.
You can get this number out of your calculator. Do you have your calculator with you?
Yep, it's going to be 21,000.6.
Point
0.6?
Okay. So what they're basically saying is that you start with $21,000, and if you can earn 5.3% per year, at the end of 7 years, you're going to grow it to 30,000.
Okay.
In other words, it's going to increase by about 50%. And that makes sense. That's a ballpark figure. It's kind of a good idea to know how fast money grows.
Okay.
Used to be, I can kind of remember back when I was younger when you could get 8% per year on your money. It took like 7 years to double it.
Really?
Yeah, because it's compounded. In other words, it's not just 7 times 8. You don't just increase it by 56%. Because at the end of the first year, your $100 is worth $108. And then you're getting 8% on 108. And then at the end of the second year, it might be worth 117. Now you're getting 8% on 117. So compounding interest is what makes it grow much faster than one would think.
Okay.
In other words, if I just multiply 7 times 5.3, that's only a 36% increase. But this clearly is increasing almost 50%.
Got it.
All right, let's see.
19's the next one.
Okay, good. I was just going to ask. All right, well, I'm going to leave the general formula there because that's always where you want to start, and then you plug in whatever 3 variables they give you.
Got it. Okay. Okay, so let's see. Is the money amount is that R?
No, this is a little tricky.
Okay.
What would A be if P is 1525, right?
Mm-hmm.
Well, if they want to triple 1525, what does A have to be?
With that divided by 3?
Times 3, 4575. Okay, so that basically says that how long is it going to take 1525 to become 4575 given a rate of 7.1%? Well, I'm going to turn that into this. Now I only have one variable, t, so I can solve for it, but
Mm-hmm.
now I need logs. In other words, I am looking at an exponential equation, not an algebraic one. There is no algebraic way to solve this. If you did not have the use of logs, you could not figure this out. And that
Okay.
might include having your calculator. It depends on how well you knew how to use your calculator and what kind you have.
Okay. I have a TI Inspire.
Okay. I
And
still
I know.
think you need the use of the logs. You'd have to know how to convert this to a logarithmic expression.
Okay.
You might be able to enter this in like that, and there probably is some key on that super calculator that lets you solve for the variable without doing the work, but that would be a feature that they would turn off
Mm-hmm.
whenever they're testing you.
Right.
Okay, so we wouldn't want to use it anyway. So let's make sure we can solve this with logs. Now, for me to solve it with logs, I got to isolate that part of it.
Okay.
So very first thing I'm going to do, that t is not affecting the 1525. It's only affecting the 1.071. So I
Right.
basically got to get rid of the 1525. So I'm going to divide both sides by 1525. Gives me 3 over there and 1.071 to the t power there. So already I've made it far simpler. Now,
Okay.
for me to convert this to logs, I could go back and use the conversion that I taught you, but the best thing to do is to treat it like an algebraic equation. Take the log of both sides.
Okay.
Remember, in algebra, you can do anything you want to the left side of the equation as long as you do it to the right.
Got it.
And that includes doing exotic stuff like logs and derivatives in calculus and integrals in calculus and just about any math process you can think of. You can do it to the left side, you can do it to the right. Now, remember Rule 3? Rule 3 says that if I have the log of some number raised to a power, I can take that and bring it down in front.
Right.
So I'm now allowed to do this. Now I've turned it into an algebraic equation. No longer have my variable in the exponent. And now the next step is dividing both sides by that coefficient. It's not in the normal spot that most coefficients are in. Usually the coefficient is in front of the variable, but
Mm-hmm.
nonetheless, that's a number. Okay?
So why are we using natural log instead of normal log?
You could use either one.
Oh, okay.
It's not like common is normal. The normal one is actually the natural log.
Oh, okay.
in terms of which log describes our universe in the best possible way, it's natural log. By a lot. Not even close. Like I said, when you get to calculus, you won't even talk about the other log functions. Everything's natural log. Okay? So this is the solution. Now, when I say it doesn't matter which log you use, it's true. That ratio is exactly the same as this ratio. Common log. There's no difference.
Okay.
In fact, it's the same as log base 17 of 3 divided by log base 17 of 1.071. In other words, the base that you use is irrelevant because when you solve for t, it's always 1 log of some number divided by same base log of another number.
Okay.
Okay. I cannot get that number directly out of my calculator, although I guess with the Inspire you can. But it used to be that your TI-84 calculator only had 2 keys. One was common log and the other was natural log. And so everything had to be in terms of common log or natural log, or you had to use the change of base formula. But with an Inspire, you can actually enter whatever base you want in there, and you don't even need the change of base formula. The Inspire is such a super calculator that
makes sense.
If it gets any better, they won't need to teach math to anybody anymore. I say that only partially in jest. It really is true. You got to think that at some point in time, why do we need to do all of this if the calculator can give us the answers? But there is a reason why.
Yeah, that's true.
And the reason why is that the purpose of math is not so much so that you know how to do stuff like this. It's to improve your critical thinking skills. The world is a quantitative place that we live. And being able to do math means you have developed your critical thinking skills. So even if you never ever have to use logs again in your life, this is still not a useless exercise. So number 20. Next.
Yep, number 20.
Okay, fill in the knowns.
Okay, so let's see.
They've given you 3 numbers. They've given you that number, $1,000, and 5 years.
Okay. Would A be $1,000?
That's the final amount.
Okay.
What's P?
So that's equal to 747.26.
Okay. What's T?
And then 5 years.
Okay.
So we're looking for R?
Looking for R in this case. Okay. Now, I'm thinking this is such a contrived question because you would never ever get this in nature. I guess you'd get it if you went to a bank and said, I want to turn 747 into 1,000 in 5 years. Can you give me this rate? And they might have to do this calculation. Let's see. We certainly don't want to take that to the 5th power and expand that as a binomial. Obviously, that is not something we'd want to do. So to solve for R, let's first of all get rid of this 747. So what's 1,000 divided by 747.26? Do that on your calculator.
1.33822.
1.338. Oh, Well, I got to round it off to something. I'll round it off to that. And that's
Okay.
equal to 1 plus r to the 5th. Well, the easiest way to handle this, even though this is algebraic, the easiest way to solve it is by using logs again.
Okay.
I'll show you why. I'm going to, first of all, take the log of both sides. And I just, out of habit, use natural log. And then that allows me to bring my 5 down to there. And now just a second, I'm thinking. You cannot distribute that. That is not the natural log of 1 plus the natural log of r. In other
Okay.
words, natural log does not mean multiplication. It's more like the f of x. Okay, that doesn't mean f times x. It means a function, f, on the other side of whatever equation is going to have nothing but x's on it.
Okay.
Why is this giving me problems? I'm not sure why. Let me think for a second. Let me go back and make sure that we're supposed to use compound. Yes, we are. Well, let's see. I move the 5 over. Oops. Sorry. Hold on.
That's fine.
I get that divided by 5. Remember, that's just a number. That's what we have to keep in mind, is that that's just a number. So now we have this. Oh, okay. No, not okay. Huh. Now I remember how to do this. Wasn't to use natural logs at all.
Oh, okay.
If that was an algebra equation, how would you solve it?
Probably square root by 5 on both sides.
Take the 5th root.
5th root, my bad.
Huh? So I'm going to take the 5th root, which is the same as doing that. And that gets rid of my exponent, 5. So now I have that. So what r is equal to this number minus 1. So 1.338 to the 1/5 power, and you can get that number out of your calculator, minus 1. And that is what r equals. And r will be a decimal. It should be like 0.06 or 0.04.
Yep, it's 0.059.
Which means the interest rate that you would be required to earn would be 5.9% in order to turn 747 into 1,000 in 5 years' time. Yeah, I got confused by logs. Well, that's a good thing to notice why we shouldn't have to use logs. we really only need to use logs if our variable is in the exponent. And the variable was not in the exponent here. So I shouldn't have needed to use logs. It's just been a while since I've done that problem, so I forgot. All right, what next?
Next one is 25.
Okay, and here we're doing greater than annual, which I kind of write like this. And remember, this is similar, only there's an n, which is how often per year are we going to compound it. And instead of t, it's nt. Okay, so let's erase this one and leave this one. And this is the one we're going to use for all of these questions that are in this section.
Okay.
You said 25?
25.
Okay. So here we're trying to solve for r again. That's good. So let's fill in. That means we don't have to use logs because r is not in the exponent.
Mm-hmm.
So tell me what I should put in for as many of the variables as I can.
So let's see. 5,000 would be A.
No, read it carefully.
No?
How long would it take 5,000 to double?
Oh, so it'd be 10,000 would be A.
P is?
P would be the 5,000?
The beginning amount. You always have a beginning amount and an ending amount.
Okay. Let's see.
What's n? Oh, no, I'm sorry. On 25, we are going to solve for t. Excuse me. We will have to use logs because they give us r. What's r?
R would be the 9.25?
0.0925. Always got to convert it to a decimal. What is n?
2?
N is the number of times per year that it's compounded. Read the whole sentence.
Daily, so 365.
Yes.
Okay.
Now, up here, n is still 365, but t is what we're solving for. In other words, they're asking us how long it will take you to double $5,000 at this pretty high interest rate. Well, if I'm solving for t, I know I've got to use logs.
Okay.
Because the variable is in the exponent. So the first thing I want to do is get rid of the leading 5,000. So divide both sides by 5,000, you get 2. Combine this probably is the next easiest step. Give me what that should be in the calculator.
Sorry, give me a second. GoToMeeting's being funny for me.
Oh.
It just shrinked the whole page.
Huh. The audio has been okay though? Usually when GoToMeeting gets flaky, the audio will get flaky.
Yeah, I think I...
Well, you see what I've circled there? Connor, can you hear me okay?
Yeah, I can. Sorry, give me a minute. I'm trying to get the screen back up.
Okay, that's all right. Give me a holler when you're ready.
Okay. Oh, now it's all fuzzy. That's okay.
Put the number, well, need to see this equation. You got to, are you unable to see my screen at the moment?
Oh, I can see it now. There we go.
Okay, Cool.
Okay, I got it.
You just check and make sure that it hasn't taken you offline. No, you're still online. Okay. So the easiest way to solve the next step is to figure out what that number is that I've got circled. In other words, that's not the easiest number to convert, even using your calculator. Go ahead and divide 0.0925 by 365. Tell me what you get. I can add the 1.
Okay. Your total is going to be 0.00025.
Okay. And notice why that's not so bad. Even though we're taking it to some giant exponent, it's a number really close to 1. So it's not going to grow that fast. Okay.
Right.
So now I have this equation, and I'm still trying to solve for t. Well, remember, whenever your variable is in the exponent, you got to solve it by taking the log of both sides.
Okay.
You could take common log if you're more comfortable with it. It doesn't matter. There's no reason you have to do natural log.
Okay.
When you get your answer, if you have to give a decimal answer, then you'll get the same answer whether you use common or natural.
Okay.
Now, what's the next line? This is the key, is what you do from this step here.
Okay. We can take that 365t and put it in the front.
Okay. Now what? Remember,
we divide both sides by that?
That's just a number. Don't think of that as a variable. It's not a variable. It's a number. You're going to get it out of your calculator, but it's a number.
Okay. Can we divide both sides by that?
That's for starters. Yeah. We'll divide the left side by that.
Okay.
And that gets rid of it from the right side. Now, one last thing to get t.
Let's see. Divide by 365?
Yeah. And how? Nah, I've written it too far to the left here. Let me rewrite it. When I divide both sides by 365, that 365 becomes a multiplier on that natural log. And in fact, if I wanted to, I could make this the exponent of 1.00025.
Okay.
In other words, I've solved for t, and this is actually the best answer you can get. In other words, even though they've said, give me a number of years, so you'll want to pull this out of your calculator and round it off to some number of years. But if they wanted real precision, this is the most precise answer.
Okay.
Okay. In other words, each of these are irrational numbers where when you get it out of your calculator, you necessarily are going to have to round it off.
Got it.
To what degree, I don't know. That's between you and your teacher. I don't know whether they always want you to round it off to two decimal places, or you can tell that 2 decimal places wouldn't work very well when we're talking about natural logs of numbers like that.
Right.
That's 5 decimal places right now. So, all right. What next?
Next one is 26.
Okay. Let me go back here. So we start with the right general equation. And fill in everything that you know here.
Okay. Let's see. I think 20,000 would be A.
Okay. Start over here.
Would P be?
Read the question, the first two words.
What principal?
That means P is going to be the variable that I'm going to be solving for.
Got it. Okay. Okay. So the rate would be 0.0925?
And let's figure out what N is also at the same time.
Would it be,
Compounded monthly.
Oh, so 12.
Right. So
Okay.
1 plus, and that rate is an annual rate, despite the fact that they're compounding it monthly. That's the annual rate, okay? And
Okay.
that's what it always is, regardless of how often they're compounding.
Okay.
N, again, is 12, and T is 10 years. That is now an algebraic equation.
Got it.
Okay. And we can do the rest of it to come up with an answer for P, but I don't think you need me to help you.
Okay.
Am I right?
Yeah, I think you're right.
Yeah. In other words, figure out what number that is, add it to 1, take it to the 120th power, and then whatever you get, divide 20,000 by that whole number, and you've solved for P.
Got it.
So it's actually simple algebra even. And I think we'd be better off spending our time setting up more problems. Because that's the difficulty, is setting them up. It's not doing the algebra. It's not even applying the logs. It's setting up the equation.
Right.
The next one 27 or different?
The next one's 27.
Okay. So what do we know here?
Let's see. Compound interest. Is a curiosity to exercise $10 in account. So are we looking for A?
Well, this sentence, David decides to invest $10. That means P is 10.
Okay.
Okay, so let's start there. That's 10. What else do we know?
Give me 1 second.
It's going to be compounded 10 times per year. That means N is 10.
Okay.
Is that enough time? He wants it to happen in 10 years. So T is 10. And he's getting a rate of 10%. So R is 0.1.
Okay.
Now, there's our equation, and the question is that enough time for $10 to triple in value? In other words, is that equal to at least $30? In other words, when we figure out what that number is, if it's less than $30, then the answer is no. If it's $30.10, the answer is yes.
Okay.
Or I should say if it's greater than or equal to $30. And that's all we're doing there, is what we're really doing, we don't even need to put the 30 over there. We're trying to put a number on this number right here. That's what the $10 is going to be worth, is A. So we're going to solve for A. If A comes out to be 29, then no. If A comes out to be 30.29, 0.001, then the answer is yes. But we're basically solving for A.
Okay, makes sense.
All right, let's go set up another one. What's the next one?
Next one is 34.
Okay, looks like I need to pull up the other page. Oh, no. Okay. Let's see. Hold on. Yeah, I can see it. Okay, this is continuous. Notice PERT. That's the way I memorize continuous.
Okay.
And the E is always there, and the R and the T are both exponents.
Okay.
First two variables are on the algebra line. The next two are both in the exponent. Okay, 34. Okay. Tell me what to fill in.
Okay, let's see. Would 20,000 be A?
Yep. When
Okay.
A will be worth, that means it's A.
Got it. Let's see. P.
What principal should be deposited? P is what we're solving for.
Okay.
E is not a variable, that's a number.
Okay.
R is what?
0.0375.
0.08375. In other words, your first step is just to move that decimal point 2 spots to the left.
Got it.
And T is 10 units. Again, this does not require logarithms or anything special. We're solving for something that's on the algebra line. This here is just a number.
Okay.
You know how to get that number out of your calculator? And you know the E button? Push the pi button and it gives you a you got the Inspire, right?
Mm-hmm.
Yeah. I don't know if it has an E button on there, but if you
it does, yeah.
If you push the pi button, it gives you a choice of E or I or any of the other special numbers.
Okay.
So that's how you get E. You might also get E by pushing the letter E on your keyboard. I'm pretty sure that it interprets that as Euler's constant, which is this E. But one way or the other, you should always have an idea that E is approximately 2.71. That way you can kind of make sense of an answer. In other words, if I told you E squared was equal to 100, well, that's impossible. You don't square 2.71, you get 100. You don't get a number above 7 or 8. So it's worth knowing approximately what E is, just so you can check your ballpark answers.
Okay.
So again, all I'm going to do is come up with a number for what I have circled, divide 20,000 by that number, and that'll tell me my starting principal.
Okay.
Okay. Go on.
Next one is 35.
Okay. Okay, this guy needs 20,000 in 5 years.
Uh-huh.
And what he's investing is 12,500. Now, the fact that it's in euros as opposed to dollars or Deutschmarks doesn't matter. You can ignore that for the purpose of solving this. Just know that your answer is, if your answer is a dollar amount, it's in euros. Okay? I don't think it's going to be here. In other words, the problem really is can you grow 12,500 euro dollars into 20,000 in 5 years at 8.6? Well, let's see. 20,000 equals 12,500. Continuous compounding, so it's E, R is 0.086, and T is 5. So whenever I've written this as an equation, but we really don't know if it's an equation, right? In other words, the left side is the unknown. Question is A going to come out to be greater or less than 20,000? In other words, this could be a little confusing if you first looked at it. If I do it like that, first of all, that might not be an equation. What's on the right side of the equation may not equal 20,000. So
Right.
you should put a little question mark above the equal sign. That's really the best way to do it. And furthermore, if you looked at this, you might think, well, the variable is E. The variable is what I'm solving for, but it's not. E is not a variable. It's a number. So I'm really solving for the left side of the equation. But what you're really going to do is get that number out of your calculator. And
19,215.7.
19,000 what?
215.7.
Okay. So the answer to A is no. He will not meet his investment goal. If not, find the minimum rate of interest where he would. So what equation should I write?
20,000 is equal to 12,500 to the power of R times 5.
Perfect. Now, again, we have an equation that has the variable in the exponent. Tell me how to solve it.
Okay, let's see. Divide by 12,500.
Okay, what do you get on the left?
8/5 or 1.6.
Either one is fine.
Okay.
That's equal to E to the 5R. Okay, I just switched the order of the R and the 5.
Okay.
Now what?
So natural log of 1/6.
Which
Or
means
1.6, my bad.
of 1.6, right? But that means I have to take the natural log of the other side also.
Got it.
Okay, now what's the next step?
Let's see, that's 0.47.
No, don't do that yet.
Oh, sorry. R to the 5th. So, or R times 5, my bad, 5R. Divide by 5.
So the right side becomes this, right? Now, natural log of E is equal to 1. Anytime the base is equal to the argument, the answer is 1.
Okay.
And the base is E. And the argument is E. So likewise, the log base 7 of 7 is equal to 1. Whenever my base is equal to my argument, it's 1.
Okay.
Okay? Which is nice. That means I can just erase it.
Okay.
So,
divide by 5?
Yep. So R ends up being equal to the natural log of 1.6 divided by 5. And make sure that you don't say the natural log of 1.6 divided by 5. That's not the same thing.
Got it.
Be very careful about your fraction bars and parentheses when you're dealing with logs. For one thing, if I were to write it accidentally like this, well, notice that that's the natural log of 1.6 minus the natural log of 5. In other words, I can use rule number 2 of logs.
Got it.
And this clearly is not going to be the same as this over here.
Right.
So this is definitely, you would take the natural log of 1.6 in your calculator and then take that number and divide it by 5.
Okay.
All right. Connor, nice working with you again. You good to go?
Yeah. Sorry?
Are you good to go for this evening?
Yeah, I think I'm good to go. I do have a test on Tuesday.
My Monday is fairly open right now. Here, let me pull it up just
Okay.
so you can have a peek at it. Yeah, I'm open until 7, and then I got an hour and a half after 7. You want me to put you down?
Can I do something at 4? Oh wait, you said you have an hour and a half after 7?
You're looking at it. Everywhere that it's white, I'm open.
Okay, is there anything after 7, or is 7 your
No,
latest?
I got a 7 to 8 scheduled and an 8 to 8:30 scheduled.
Got it. Okay.
Anything prior to this, you can have.
Can you do 4:30 to 5:30?
Yep.
Okay.
Make sure it still finds you. Yeah. Is that still your right phone number?
No, it's different.
You know what? I'm just going to take it off there because I've got your right phone number in my contacts because I called you. I mean, I got a hold of you, so make that 5:30. In other words, I don't need it to be correct on my calendar. I just need it to be correct in my contacts list. Connor, I will text you the meeting ID number at 4:30 on Monday. Tomorrow.
Awesome. Thank you very much, Mr. Cowan. I appreciate it.
Bye-bye.